guys, this is Vaishnavi and welcome to the video. Today we are going to look into a topic about requirement gathering technique. I hope it would help you a lot and I hope you would like this video. If so, hit a like and drop your valuable comment. What is the requirement, guys? A thing which is needed or wanted, right? Similarly, requirement in software engineering conveys the expectation of a user from a software product. That is the user's need or want. And elicitation is so-called engineering word for collection or gathering. What is requirement gathering technique and what are they? Requirement elicitation is the process of collecting information from a stakeholder or an user. It serves as a foundation in documenting the requirements for application development. There are a number of elicitation techniques to gather requirements and to collect the information from a stakeholder. In this video, we are going to discuss about a particular requirement elicitation technique called reverse engineering. So let me quickly show you the objectives of this video and we get started. Yeah, these are the objectives of this video. Like what is the reverse engineering, why it is should be used, and stages of reverse engineering, why it is a powerful requirement technique, and principles, benefits, ethics of reverse engineering, and the overall review. Over the past 120 years, manufacturers around the world have produced millions of machine products and their parts. Due to this continual advances in millions of new technologies, few of these products have remained relevant for more than several years of initial release. However, numerous old parts have used in machines have stood the test of time. When the part malfunctions or breakdowns, you just replace the component, not the whole device, right? This is what called the reverse engineering. In any given factory or office building, you are likely to see manufacturing or computing system comprised of sophisticated equipment. Typically, the parts in question will range in from new to more than 20 years. For these systems to remain intact, various components must be reverse engineered and recreated. What is the reverse engineering? When a migration project does not have access to sufficient documentation to the existing system, reverse engineering will identify what the system does. It will not certainly identify what the system should do or like what the system does is the wrong thing. No, it will just identify what the system does. This elicitation technique is generally used in migration projects. If an existing system has an outdated documentation, it can be reverse engineered to understand what the system does. This is an elicitation technique that can extract implemented requirements from the system. Engineering is the profession involved in designing, manufacturing, constructing, and maintaining of the product systems and structures. At the higher level, there are two types of engineering. One is forward engineering and second one is reverse engineering. Forward engineering is a normal kind of traditional process of moving from higher level abstractions and lower level designs to the physical implementation of the system. The process of duplicating an existing component, subassembly or product without an aid of drawing or documentation or not even with a computer model is known as reverse engineering. Reverse engineering can be viewed as a process of analyzing a system to identify the system's components and their relationship. There are two types of reverse engineering techniques. They are black box reverse engineering and white box reverse engineering. Black box is kind of studying the products without examining its inner structure and functions, whereas the white box is like studying the inner structure and the functions. Let us see why this reverse engineering should be used. Whether it's a rebuilding of a car engine or diagramming a sentence, people can learn about many things simply by taking them apart and putting them back together again. That, in a nutshell, is a concept behind reverse engineering. Breaking something down in an order to understand it, build a copy, or improve it. Reverse engineering is used to many purposes as a learning tool. As a way to make a new compatible products, they are cheaper than what's currently on the market, for making software incredibly more effectively, or like bridge data between different operating systems or databases, and to uncover the undocumented features in an uncommercial product. So let's see the stages of reverse engineering. There are three stages in reverse engineering. With forward engineering, developers first analyze an application and prepare a model of its intent. Only then they do design and the application, that is, choose strategies for solving the problem. Finally, they implement the application by writing some kind of database or code. You can reverse engineer by constructing models that describe the existing software and pre-assumed intent. This process has three main stages: implementation recovery, design recovery, analysis recovery. See, implementation recovery is where you prepare an initial model that forms the basis for reverse engineering, because the initial model will serve as a reference, right? It should purely affect the implementation and have no inference. First task is to browse existing document and learn about an application, whether it might be an existing application without a documentation or with the documentation. The resulting context clarifies the developer's intent and make it easier to communicate with application experts. You should finish the task within a few hours, and what you learn is incidental to actual reverse engineering, but it's more important because it helps you to notice as more as you proceed. And the second stage of reverse engineering is design recovery. During design recovery, you can undo the mechanics of the database and perform only the straightforward actions. You should postpone the conjecture and interpretation until the analysis recovery stage. Typically, you can perform the design recovery autonomously without the help of any application experts. During this stage, you can resolve three main issues. They are identity, foreign keys, and queries. And there is the last stage of this reverse engineering, that is analysis recovery. This is the final phase, and it is so called analysis recovery because it interprets the model and refines it, make it more abstract, and it is primarily during the phase that should consult with the available application experts. Analysis recovery consists of four main tasks. They are clarification, redundancy, errors, and model integration. So let's see why reverse engineering is powerful and why it is considered as a powerful requirement technique. This is the very basic question that everybody should answer themselves before getting involved into reverse engineering. Reverse engineering product features into requirements allows you to build comprehensive requirements profile, which is the foundation for a successful software evaluation. This requirements profile is unique to an organization and is the basis against which potential software products are evaluated. It is also used when implementing the software that will be subject for the future post. Reverse engineering is very common in such diverse fields as software engineering, entertainment, automotive, consumer products, microchips, chemical, medical, many more designs. For example, when a new machine comes into the market, competing manufacturers may buy one machine and disassemble it in order to look how it was built and look how it was working. A chemical company may use a reverse engineering to defeat a patent competitor manufacture process. In a civil engineering, bridges and buildings designs are copied from the past success. So there will be a chance of getting their success, right? Catastrophic failure too. In software engineering, good source code is often a variation of the other good source code. This is the most familiar question that I have heard while someone tries to reverse engineer, like, is reverse engineering appropriate for my project? Yeah, this one must be answered. Reverse engineering is a useful tool when gathering your project requirements. It shouldn't be used as a main technique, but it will provide you some valuable insights at the starting of your project. Times when you will find reverse engineering with the current product, you should ask like, you should do this reverse engineering while the situations like when there is a no documentation with the current product, when there is a current product with the system is legacy item, when the key knowledge is left behind the company and the records weren't kept, when the current system has a product that has developed organically with no solid pan. So let us look into our principles of reverse engineering. Don't mistake hypothesis for conclusion. This literally means, see, reverse engineering yields hypothesis. You must thoroughly understand the application before reaching from conclusions. You should not you should not guess, like you should conclude it, okay? And the second principle is accept multiple interpretation. There is no single answer as in forward engineering. Alternative interpretation of database software can yield different models. The more information that is available, the less judgment should vary among the reverse engineers. And the third principle is don't be discouraged by approximate results. And the last principle is watch for a consistent style. Yes, databases are typically designed, using this consistent strategy. Including consistent violations of good design practice, you should be able to deduce the underlying strategy. So this is all the principles involved in reverse engineering. So let's look into the benefits of reverse engineering. Engineering is a very versatile industry that is always getting creative. Using creativity and innovation, engineers can create never before seen products that benefit their communities. They play a key role in expanding local economy and sparking the business exchanges. However, one question remains. How do engineers innovate in such fast-paced environment? The answer is reverse. Yes, literally reverse engineering plays a huge role in sparking innovative and productive minds that produce necessities across every industry. The reverse engineering, the process includes taking apart worn down products and to examine how individual product works. They used to invent into new ones. There are plenty benefits in this reverse engineering process that will only expand our knowledge and capabilities. So guys, yeah, the bottom line is that reverse engineering is kind of a thing which deepens your understanding for a vendor's project and helps you to make better decisions. The payoff is striking when you consider that a software purchase and the deployment can cost millions of dollars and that a reverse engineering assessment can be performed in as little as a few weeks. So we shall move on to the ethics regarding reverse engineering. There are some ethical aspects involved in reverse engineering. Let me tell you with an example. When I reverse engineer vendor software, my purpose is not to uncover my secret or vendor secrets so that my clients would recreate the software. No. First, that would be unethical. Second, re-implementation is usually uneconomical, right? I would view it as a last resort. Rather, my purpose is to assess the software's merit to get past the hidden assumptions and the sales claim. Reverse engineering deepens my understanding of a product and lets me communicate with the vendor. Some vendors find reverse engineering as a threatening, but it's not at all, guys. It's not at all threatening. It is threatening to only to the inept vendors. The super vendors can, they should welcome the technology. It makes their excellence visible for all kind of manner that is much more credible. Or even like a sales ad, guys. This kind of credibility cannot be bought. I can sure on it. Reverse engineering exposes the strengths and weakness of a product and causes an evolutionary bias towards excellence. Reverse engineering induces vendors to upgrade their software engineering practices so that they can survive the scrutiny. Yeah, so there are some ethical aspects involved in this reverse engineering. Okay, guys, let us conclude our reverse engineering topic. So, we shall have an overview of what we have discussed in this video. Reverse engineering can help you see inside a product and find the hidden strengths and weaknesses. This lets you to judge a product more deeply and reach beyond a typical criteria of functionality, cost, or like vendor stability. Yeah, none of the typical criteria can directly assess the intrinsic quality of an application, but you can assess it with the reverse engineering. Yes, when you consider the high cost of many software deployments and low cost of reverse engineering, it's just a few weeks of effort that benefits you more than anything. It is truly a bargain. Reverse engineering as a way to gather your project helps you to understand good and bad points of what's already there. Rarely you will be asked to reinvent the wheel. Take advantage of what people have done before you, both inside and outside of your company, to learn from their mistakes.
Thanks for watching this video, guys. I hope this video helps you a lot. This is Vaishnavi and I'll be back with another interesting video content. Until then, stay safe, stay home. Bye bye.